On the plains of Emilia-Romagna in northern Italy, the future of Italian agriculture is taking shape.
We are in an experimental field where we're comparing different varieties of durum wheat. On that plot over there, we've planted 30 or so different varieties. We can already see from here certain differences in color or size.
Luigi Cattivelli leads a team of researchers who are testing new plant varieties on these fields, with the aim of developing organisms that are capable of resisting global warming.
A plant that can resist climate change is a plant that can resist various diseases, that'll stay healthy. A plant with deep roots capable of efficient water management. Obviously, a strong resistant plant that can grow with less water.
Producing wheat, despite the increasingly difficult climatic conditions, has become a strategic challenge, as it is the key ingredient for pasta, Italy's most iconic dish worldwide. To test the plant's resistance, certain plots are deliberately exposed to diseases.
Here we have injected artificial infections. We have to give the pathogens time to develop and get into the leaves so the disease can grow. Then we rate the resistance of each plant from 0 to 9. 9 for those that are sick and 0 for those that are resistant. This one, for example, I'd say was a 4.
Each plot is regularly monitored
Moving to start point.
and also observed from the sky, thanks to drones that photograph the 17 hectares of wheat grown here.
With just one flight, a drone can monitor various plots. That allows us to see, for example, the different nuances of green, which is an important indication of the health of the plants, their size, if they have flowered or grown their spikes. All this information could be collected on foot, but the drones do it much quicker, efficiently, and cheaper.
Some plants are grown in controlled chambers. The aim, to accelerate their growth and shorten the genetic improvement process that normally takes years. Then, in the laboratory, the scientists move from the plant to the genome. Under the microscope, this researcher can try to identify the wheat genes for improved varieties.
At the moment, we're working on research aimed at increasing the size of the grains in order to improve productivity. We're studying the relevant genes involved in the size of the grains to make them bigger and longer.
A race for innovation that pasta manufacturers are also invested in. We are in the research lab of the world leader in pasta production. Here, scientists are analysing the structural characteristics of the commercial spaghetti made by the brand.
We're analysing the surface of the pasta to the scale of a micrometer. This instrument, that resembles an old-fashioned record player, is equipped with a needle capable of following the ridges and hollows on the pasta's surface, and this allows us to analyse the coarseness.
To take things even further, the group has created a new innovation centre, 14,000 square metres, and an army of engineers, food technologists and professional tasters that work on the recipes of the pasta of the future.
This is our 3D printer for pasta. We built it here in-house thanks to this technology. We can print about 40 different pasta formats.
This is the first machine of its kind in the world. It's printing a new type of pasta called pink petal, a durum wheat pasta with an addition of natural beetroot extract.
To us, it's digital craftsmanship. The 3D printer and all the technology that comes with it has allowed us to create a new space for pasta development and new consumer habits, for example, appetizers. This pasta looks both pleasing and good to eat, as well as being very easy to cook, because you prepare them like traditional dry pasta.
And the result is surprising. Colourful pasta in unusual shapes. But behind these new products lies years of research into ingredients, textures and new consumer habits, all of which points to a long and vibrant future for one of the world's most beloved staples.